Right. Let's look at question number 11, part A of the PO paper. So this is the quadratics question. So we are given fx equals this quadratic. Lambda and c are real numbers. We need to find minimum value of fx and it show that it's equal to that. So easiest way to find the minimum or maximum of a quadratic is complete the square. Then you can find the vertex. No, the minimum or maximum is at the vertex. So complete the square for the first part. So x squared minus lambda x plus c squared. So complete the square, you get x minus lambda 2 over squared plus c squared minus lambda over 2 squared. Then x minus lambda over 2 squared plus c squared minus lambda squared over 4. Now simplify x minus lambda over 2 squared 4 square c squared minus lambda squared over 4. So this is the complete in the square form. Then from that we know this is what smallest value this can take is greater than or equal to 0. So 0. So then the minimum value this expression can take is what? This is going to be greater than or equal to, sorry, greater than, oh yeah, greater than or equal to 4c squared minus lambda squared over 4. So minimum fx is what? 4c squared minus lambda squared over 4. So that's from the complete in the square form. So if they ask where does it occur, that is at x equals lambda over 2. So write it in the vertex form, the quadratic, then you get the maximum in point. In this case, it's a minimum. So graphically, graph would look something like this. This is your vertex. This is not necessary. This is the minimum point. You don't need to write that. You just need to show this. Right. Then what are they saying? Uh, this graph of y equals fx, this is that parabola, has two distinct intercepts with the intersections with the x-axis. So it has two x-intercepts. So something like this. It has two x-intercepts. So two roots. This quadratic should have two roots. Right. So if that is the case, we have to show what? This is true. Lambda is greater than 2 absolute value of c. So a quadratic has two roots if what? Discriminant is positive. So use that. B squared minus 4ac has to be greater than 0. So what is b minus lambda? Minus 4. A is what? A is 1. C is c squared. Right. So 1 into c squared, that has to be greater than 0. So what do you get? Lambda squared minus 4c squared is greater than 0. Or lambda minus 2c times lambda plus 2c is greater than 0. So this means what? Lambda has to be less than minus 2c and greater than 2c. So that is if C is positive. If C is negative, the other way. So then we can just combine this into what? These two inequalities just turns into what? In absolute value form, it will be lambda is greater than 2 absolute value of C. If we combine these two inequalities together, you get that. Because remember, it is minus C, C. We have this section is given by what? Lambda less than absolute value of C. Then the other two sections are given by lambda greater than absolute value of C, or this case 2C. So minus 2C to 2C. So middle section is less than, then the other two sections are the greater than part. Right. So then that part is done. Then what are you supposed to do? Alpha and beta are the roots of this, and alpha beta both are positive. So alpha is positive, beta is positive. Then we need to show this. Right. So let's start. Alpha and beta both are positive. Then we need to show this expression, root alpha plus root beta expression. So using this, we'll write alpha plus beta, which is what? Minus lambda minus lambda over 1, so lambda. So let's write those two expressions first. Alpha plus beta is what? Minus lambda over 1, which is lambda. And alpha beta is what? C squared over 1, which is C squared. Right. So now we need an expression for root alpha plus root beta. We'll find the square of that and then use it to get the answer. Root alpha plus root beta is squared is what? Alpha plus 2 root alpha beta plus beta. So then this is equal to alpha plus beta plus 2 root alpha beta. So then we can write this as alpha plus beta is what? Lambda, and lambda is also positive, right? Why? Alpha and beta both are positive. So lambda, then root alpha beta. So plus 2 C squared inside. So square root of C squared is absolute value of C, because we want the principal value of the square root. So that is the positive value. So we have root alpha plus root beta squared is equal to lambda plus 2 absolute value of C. Then we want root alpha plus beta. So take the square root of both sides and you have the answer. That's what we want to show now. Yes. Right. So we need to take the positive answer, because why? Alpha is positive, beta is positive, then obviously square root alpha and square root beta are positive. Right, that one is done. Then using that, we have to create the quadratic with these two roots. So let's find the sum of these two roots and the product of these two roots. So root alpha minus 1 over root alpha plus root beta minus 1 over root beta. System tedious work. Root alpha plus root beta, then combine these two using the combine these two into a single fraction, taking the common denominator. Root alpha plus root beta over root alpha beta. So this is the sum of the roots of the expression we want to find. So apply this lambda plus that minus lambda plus 2 absolute value of c. Root alpha beta is what? Alright, alpha beta is this, so root alpha beta should be absolute value of c. Right, don't simplify it further. If we need to simplify it further, we'll do it. Just leave it like this. Right, then find the product of these two. So we have the sum. Now we need the product. Right. So you get alpha into beta, square root alpha beta, then minus square root alpha over square root beta, minus square root beta over square root alpha, then minus 1 over square root alpha beta. Right, now simplify this. So what do we have? Square root alpha beta, which is modulus c, then combine the last three terms. No, this is plus. No, sorry, this is plus. Minus minus becomes plus. Let's combine these two terms first. These two, let's combine first. You get what? Alpha plus beta over square root alpha beta, and plus 1 over square root alpha beta. So let's see then. So modulus c minus alpha plus beta is lambda. No? This is modulus c plus, right. So then let's put it under modulus c, the common denominator. So then c squared minus lambda plus 1. Right. So this is the product of those two roots. So then we can write the quadratic with those two roots. X squared minus sum of the roots times x plus product of the roots equal to 0. So that is how we create the new quadratics. So sum is what we found. Okay, this one. So substitute for the sum this part. X squared square root lambda plus 2 absolute value c minus this plus this over modulus c x, and then this part. This is the product. C squared minus lambda plus 1 over modulus c equals 0. Right. Let's see if we need to further simplify this to get the answer. Right. Okay, there's no denominator, no? So just we need to simplify this further to get this answer. Right. So just multiply out the denominator. Multiply by modulus c or absolute value of c. So you will get what? Take the common term out, which is this one. And first term you have a modulus c minus 1 x plus c squared minus lambda plus 1 equals 0. Let's see if that is the answer. Yes, we have that. Yes, we have that part also with minus right? And yes, correct. So let's check. Right, that's what we want. Right, that's the quadratic. Now what? Okay, take this quadratic as gx. So this as gx. So that quadratic is going to be gx. So then they are saying y equals fx and y equals gx intersect the y equals f intersect uh, in the y axis. So their intersection point is on the y axis. So these two quadratics will intersect like this. There's two quadratics, they will intersect at some point like this on the y axis. Then we need to show that it is lambda equals 1. So if they intersect in the y axis, that means x value is 0. So equal the two equations and substitute x equals 0 to that. Then you should get the answer. So y equals fx and y equals gx intersect, and they intersect at the y axis. So that means x value is 0. X coordinate of the intersection point is 0. So how do we find intersection points? Equal the two curves and solve that equation. So what is the equation of fx? X squared minus lambda x plus c squared. Gx, right, gx is this one that we just found, modulus c x squared minus root lambda plus 2 absolute value of c x. No, there's more to that. Modulus c minus 1 x plus c squared minus lambda plus 1. Right, point of intersection is given by this equation, and we know the x value of the point of intersection is 0. So substitute that into this equation. So you will get what? 0 0 plus c squared, 0 minus 0 plus c squared minus lambda plus 1. These cancel, you get what? Lambda equals 1, which is what we want to show. So that is the answer for the first part of question number 11. Question is not that hard, just tedious work, just simplification and stuff, unnecessary stuff. Right, then we'll do part B next.